Welcome to the deep dive. Ready to get granular.
Always.
Today we're diving deep into the world of filtration.
Sounds messy.
Well, it can be, but it's also essential. You
Yeah.
know, separating solids from fluids is everywhere.
Oh, absolutely. It's way more than just your morning coffee.
Right. Think clean drinking water, the air we breathe, even cutting-edge medicine.
It really is fascinating how fundamental it is.
Totally. And for this deep dive, our guide is a paper from Dr. Tamer H. Hassan from Suez Canal University.
Oh, excellent choice.
We're going to break it all down. The science, the types of filtration, even some surprising applications.
I love the surprising one.
You'll be a filtration pro by the end, I promise.
No doubt.
Okay, let's start simple. What exactly is filtration?
Well, Dr. Hassan defines it as the separation of an insoluble solid from a fluid by means of a porous medium.
Okay, so like a sieve separating sand from water.
Exactly. That's the essence of it.
So we've got our fluid, which can be a liquid or a gas, and our solids we want to remove. But what do we call that mix before it's filtered?
That's our slurry or feed. And as we filter, the solids build up on the filter. We call that the cake.
Cake! I like where this is going.
And what's left, the fluid passing through, that's the filtrate.
So the filtrate is like our reward, like the coffee we get to drink.
You got it.
Now, Dr. Hassan mentions two main types of filtration. Cake filtration and clarification. What's the difference?
In cake filtration, we're after the solids. Think about extracting valuable minerals from ore.
So the cake is actually valuable.
It is. It's the treasure.
Huh. That's interesting. And then clarification is the opposite, where we want the cleaned liquid.
Exactly. Purifying drinking water is a perfect example. The clear water is the goal there.
Makes sense. So it depends on what we're after, either the solids or the clean fluid?
Right.
Okay, but how does this all work scientifically?
Well, Dr. Hassan gives us this helpful equation.
Yeah.
The rate of filtration equals the driving force divided by resistance.
Okay, so we need some force to push or pull the fluid through.
Right. That driving force could be gravity, a vacuum, applied pressure.
Oh, or like the spin cycle in a washing machine.
Exactly. Centrifugal force.
So more force equals faster filtration.
It's like squeezing honey through cheesecloth.
I get it. But what about that resistance part? What slows the fluid down?
Well, that's the filter media itself. And the cake, as it builds up,
Yeah.
they resist the flow, like the cheesecloth does with the honey.
Ah, so a tighter filter means slower flow.
Exactly.
It's a tug of war.
Pretty much.
Now, Dr. Hassan highlights 5 key factors that affect filtration rate.
5.
Yeah, 5. First up is the permeability coefficient, or specific resistance. What does that even mean?
It basically measures how easily the fluid flows through the filter and the cake.
Okay.
Think about pouring water through gravel versus sand.
Ah, the water goes through the gravel faster.
Way faster. It's more permeable, less resistant.
Got it. So some materials are just better at letting fluids pass?
Right.
What's the next factor?
The area of the filter medium, larger area usually means more flow.
Because there's more space for the fluid to pass through. Exactly. More pathways.
So bigger filter, faster filtration.
Well, not always. A larger filter can mean a thinner cake, and it might collapse under pressure.
So it needs to be strong too.
Yes.
Okay, the third factor is the pressure drop across the filter.
Right. So the bigger the pressure difference between the two sides, the faster the flow.
Back to that equation.
Exactly.
But too much pressure could damage the filter.
Right. Absolutely. Or compact the cake too much, which slows things down.
So it's a balancing act.
It is.
Okay, factor number 4. Viscosity. Honey takes forever to pour compared to water. That's viscosity.
Exactly. Thicker fluids have higher viscosity and flow slower.
So sometimes you need to heat them up or thin them out to speed things up.
Sometimes.
Makes sense. Last factor, Dr. Hassan says it's the thickness of the cake.
Right. As the cake builds up, it creates more resistance, slowing down the flow.
That's why some systems have ways to clean the cake, right?
Exactly. Wow, so many factors. So we've got our driving force, the resistance, and all these factors that affect how fast it all happens. But what about the filter itself? What are those actually made of?
The heart of the operation. Dr. Hassan breaks down filter media into 5 main categories.
Hold on, before we jump into that, maybe let's give our listener a minute to process all this.
Good point. It's a lot to take in.
We'll come back to those filter media types in a bit. For now, just think about how all these factors work together.
Yeah, it's pretty amazing.
It's a delicate balance.
For sure. It's crazy how many uses filtration has. We've been talking about coffee, mining, but it goes so much further.
Right. That's what I love about these deep dives. We start with something simple, like a cup of coffee, and bam, it's a whole world of science.
Absolutely. I mean, think about pharmaceuticals.
Oh, yeah. Keeping medicine sterile.
Huge. Filtering out bacteria, viruses, all that to get a pure, safe product.
That's intense. I bet it's a big deal in food and beverages too, right?
Yeah. Oh, for sure. Clarifying juices, filtering yeast from beer, and of course, purifying our drinking water. It's everywhere.
Speaking of water, what about environmental
Oh,
applications?
yeah, lots. Wastewater treatment, even desalinating seawater, cleaning up oil spills. Filtration is key for protecting the environment.
Wow. It's mind-blowing how one process is in so many fields, and the technology keeps evolving what's coming next.
Ooh, that's the exciting part. Nanotechnology is opening up so many possibilities.
Really? Like what?
Think filters with pores so small they can catch viruses and bacteria. Super efficient.
That would be amazing for healthcare. How does it work, this nanofiltration?
Basically, it uses membranes with super tiny pores, like nanometer size.
Nanometers. That's crazy small.
Right. So small they can even block certain molecules. Super precise separation and purification.
So a super picky sieve, but for molecules.
That's a great way to put it. We're also seeing smart filtration systems.
Smart filters. What, can they make coffee too?
Huh. Not quite. But they can monitor their own performance and adjust as needed.
What? So they can practically think for themselves.
Pretty much. They can sense changes in pressure, flow, even what's in the fluid, and then they tweak things to keep working at their best.
That's straight out of sci-fi. So are there any downsides to filtration? With all this progress, I mean?
Of course there are challenges. One of the big ones is balancing efficiency with energy use. Forcing fluid through a superfine filter. That takes energy.
Makes sense. Finer filter, more resistance, more energy needed to push through.
Exactly. So finding ways to make filters use less energy is important, especially as we aim for even finer filtration.
So it's got to be effective and efficient.
Yes. Another challenge is fouling or clogging.
When the filter gets jammed up with the stuff it's supposed to be filtering out.
Precisely. It can really mess with efficiency and even cause the filter to fail completely.
So preventing that clogging is super important.
Absolutely.
Yeah.
That's where new materials and designs come in. Scientists are always looking for ways to make filters more resistant to fouling and last longer.
Wow, it's amazing how much goes into designing a good filtration system.
It really shows how vital filtration is in so many areas of our lives.
Right. Now, before we got lost in all that cool future stuff, we were talking about types of filter media.
Oh yeah, right. Dr. Hassan's 5 categories.
Remind us, what were they again?
Woven filters, non-woven filters, membrane filters, porous plates, and granular materials. Those are the 5.
Okay, so many. What about those woven filters? What are they like?
Ah, the woven filters. They're like the workhorses.
Workhorses, how so?
Well, think like wire mesh or even fabrics. They're tough, they're reusable,
Oh, so good for industrial stuff.
perfect for it. The downside is their pore sizes are limited.
So not for those tiny, tiny particles.
Right, for those you'd want a non-woven filter.
Ah, okay, so what are those made of?
Things like felts, filter paper, or sometimes bonded fabrics.
And they can catch the really small stuff.
Excellent for it, though they can be a bit more delicate.
Gotcha. Now, we talked about membrane filters earlier. With those nano-sized pores, those sound pretty high-tech.
Oh, they are. If you need sterilization, ultrafine filtration, that's your go-to.
So like for medicine or clean drinking water?
Exactly. The downside is they clog more easily because those pores are so small.
So it's a trade-off. Super effective, but maybe not as tough.
Right.
Okay, what about porous plates? What are those used for?
Porous plates, they're often used as a support.
Support. For other filters?
Yeah, exactly. Like backing up a membrane filter so it doesn't break.
Okay, that makes sense.
Usually made from ceramics or metals.
And are they reusable?
They are. But their flow rate's not great because the pores are kind of big.
Makes sense. All right, lastly, we've got those granular materials. I remember Dr. Hassan mentioning sand and gravel, stuff like that.
Yep. Sand, gravel, things like that. Super versatile and cheap.
Oh, so they're used a lot.
All over the place. Water treatment, swimming pools,
Uh-huh.
even some specific industrial processes, though cleaning them can be a pain.
So many options. It seems like choosing the right filter really depends on what you're trying to do.
Oh, absolutely. And that's where Dr. Hassan's paper is so helpful. He lays it all out, the good and bad of each type, so you can make the best choice.
It's incredible how much goes into a good filtration system.
It is.
We've covered the basics, what affects the speed, the different types of filters.
You even got a peek at the future of filtration.
Right. Nanotechnology, smart systems, it's all pretty amazing.
Yeah, filtration may seem simple at first glance, but there's so much depth to it.
It's a reminder that even the stuff we take for granted, like coffee or clean water, depends on science and engineering.
Totally.
Well, thanks for joining us for this deep dive into the world of filtration. It's been a fascinating journey. Until next time, keep filtering out the noise and seeking clarity in everything you do.